Hello students, in the previous lecture I have discussed about the different dimension of a physical quantities. Today we are going to discuss about the different types of variables and the constant. As we know that the quantity which has the fixed value known as the constants and the quantity which has the values on the changing the value of the other quantity. That is, value of which depends upon the other quantity is called the variables. Here, there are two types of the variables and two types of the constants. First is the dimensional variables, those variables having the dimensions. For example, velocity, work, energy, power, so on so forth. Second, dimensionless variable, those variables having no dimension. Example, angle, specific gravity, refractive index. Here, there is a star on the specific gravity. It is the most important term, specific gravity. Specific gravity means the relative density. Why angle, specific gravity, and the refractive index having the no dimension? Because these quantities can be represented in terms of the two quantities having the same dimension. Angle arc upon the radius, both having the dimension of length. Specific gravity, the relative density, density of substance divided by density of water at 4 degrees Celsius. Both are the densities. So they will be considered. Refractive index at the speed of light in air divided by speed of light in medium. So both are the speeds they will consider. Third, dimensional constant. The constants having the dimension. Value is constant. For example, gravitational constant. Its value is fixed 6.67 10 raised power minus 11 Newton meter square per kg square. But it has the dimension as shown in the earlier lecture. Planck constant, it also having the fixed value, but having the dimension. Similarly, the Stephen constant, it is. Now, fourth is the dimensionless constant. Those constants having no dimension. Number 1, 2, 3, 4, so on so forth, having no dimension. Pi, E, the exponential function. These are the constants which has no dimension. So, there are the four types of the quantities. I hope you are familiar, you are known these quantities. Now, applications of the dimension analysis. Applications of dimension analysis. There are the mainly three applications. Applications are very important. Question asked from the applications. In each and every academic as well as the competitive exam. The first application, conversion of to convert a quantity from one system to other. Second, to check the dimensional correctness of any equation or formula. And third, to deduce means to find out the formula of any quantity. This formula of impact. It is the dimensional correctness and it is the conversion of the physical quantity. Here we will discuss these applications one by one. First, convert a physical quantity from one system to another. For this conversion, there is a particular formula, and that formula obtained by the simple method. Here we see that 1 is not equal to 100. Is it clear? 1 is not equal to 100. But 1 meter is equal to 100 centimeter. Is it correct? First is not correct. Here 1 is the numerical value n1. 100 is the numerical value n2. In this equation, 1 is the numerical value n1 and meter is the unit in the first system. It is the n2 numerical value and u2 is the unit in the second system. Here we see that if numerical value is small, unit will be large. If numerical value is large, unit will be small. That is n1 u1 is equal to n2 u2 and so on. So n is inversely proportional to u. Now, how the formula develop? I hope that these steps are clear. How the formula develop and how this formula utilized. n1 u1, it is the unit. Suppose that quantity is length, then unit will be L. Length meter, dimension L. If it is length dimension L, power 1. If it is the speed, LT minus 1. If it is the force, LT minus 2. LT minus 2. It is R, it is the S, it is the length. So this U1 may be the quantity having the single term, having the two term or more than two term. And power is decided. Power on the mass, length and time is decided. So in general, we have to put m1 power A, m2 L1 power B, and T1 power C is equal to n2 m1 power m2 power A, L2 power B, or T2 power C. So n2 is equal to m1 n1 of m1 upon m2 power A, L1 upon L2 power B, or T1 upon T2 power C. It is an important formula. If n1 is known, first system is known, second system is the system in which we are going to convert, and n2 is the unknown. then this formula is very useful. Take one example. Convert 1 joule into iron. Joule in the SI system or in the CGS system. First of all, you must have to know what is this quantity. This quantity is the work or energy. So we have to find out the dimension. Dimension of energy or work. ml square T minus 2. And here we see that by comparing this m power A, L power B and T power C. A is equal to 1, B is equal to 2, and T is equal to minus 2. So first step, you must have to know the dimension of that quantity. It is necessary. Here in the dimension, it is necessary to remember the dimension for each and every question. Either you are going to convert, or you are going to check the question, or you are going to establish a formula in each. Again, here, solution here, n1 is equal to 1. n2 is unknown. Apply the formula. n2 is equal to n1, m1 upon m2 power A, L1 upon L2 power B, or T1 upon T2 power C. For academic student, remember that if you are going to solve any problem, you must have to write down the formula. After this formula, you will be awarded half mark. Other step is not clear, doesn't matter. Now put the value 1, m1, m1 upon m2 power 1, L1 upon L2 power 2, or T1 upon T2 power minus 2. Here 1, m1 is in the SI system. In the SI system, mass in kg. And m2 is in the CGS system. Mass in gram, power 1. L1 is the length in SI system, meter. And in the centimeter, power 2. It is second in both the cases. Adopt this step. Again, n2 is equal to 1 kg. Your aim to convert in CGS. So kg will be converted into gram. 1000 gram upon gram, power 1. It is 100 centimeter upon centimeter, power 2. Here, second and second cancel out, 1 power minus 2. Now 1. And in the 10 raised power 3, 10 raised power 2 and square 4, 10 power 7. Value of n. So 1 joule is equal to 10 raised power 7 and 1 joule is equal to 10 raised power 7. Add the process. This formula is useful for the conversion of any physical quantity from one system to another. Is it clear or not? If you have any suspense, any problem, then you can comment me. I will discuss again. The second application of the dimensional analysis is the checking of any formula or equation dimensionally. if there is any equation, suppose that kinetic energy is equal to half mv square. Check that this formula is dimensionally correct or not. What is the meaning of dimensional correctness? We will see that there are the equations which are dimensionally correct but numerically not correct. Dimensionally correct formula, it is not necessary that it is numerically correct. For dimensionally correctness, we have to write down the dimension of left hand side, dimension of the right hand side. If the dimensions of left hand side equal to the dimensions of the right hand side, then formula or equation is dimensionally correct. If it is not so, that the dimension of left hand side is not equal to the dimension of right hand side, then equation or formula is dimensionally wrong. Take one example or two examples and then discuss. Take the example for kinetic energy. Here we have to check that whether this formula is dimensionally correct or not. So for the checking, dimension of LHS, that is kinetic energy. Dimension of kinetic energy is in the case of energy, there is kinetic energy, potential energy, total energy, and different types of energy. But the dimensional formula is same for all energy. Dimension does not depend upon the system of unit. For example, length. If length is in Fermi, minus 15 meter, very small. Millimeter, centimeter, kilometer, day, years. Length of the light covered in year. Distance. Astronomical unit distance. Parsec distance. So the each and every terms are length. So dimension is here. Either it is the parsec, either it is astronomical unit, either it is the distance covered by the light in 1 year, light year, so on so forth. So kinetic energy also having the dimension of m squared t minus 2. As we have already told you that at finally we will give a table having the same dimensions quantity, having the no dimensions quantity. Okay. Now dimension of the half m square. It is the dimension of LHS. Dimension of RHS. In the previous discussion, half is the dimension, let's see the number half. And mass, dimension of mass is m. Dimension of velocity is LT minus 1 square. So m L square t minus 2. Here, dimension of LHS is equal to dimension of RHS. So formula is dimensionally correct. Dimensionally correct. And if half is absent, then this formula is also dimensionally correct. But its numerical value is not wrong. Because correct formula is half. So the dimensionally correct formula, kinetic energy, m square. Both are dimensionally correct, but numerically formula is this. So it is the process of checking. Take another example. For inconsistency, T is equal to 2 pi L by G. T the time period of simple pendulum. L length of string. G the association due to gravity. Check where this formula is dimensionally correct or not. Adopt the same process. Dimension of left hand side. It is the time period. It is the time period having the dimension T. Dimension of right hand side. Two pi. 2 is a number, pi is also having no dimension. So this 2 pi is dimensionless. So dimension of right hand side, dimension of length, acceleration due to gravity, it is isolation, LT minus 2. L cancel out, T square. Here we see that dimension of left hand side is not equal to dimension of right hand side. Dimension of LHS is not equal to dimension of RHS. So formula is dimensionally wrong. Is it clear? I hope that you will check the correctness of any formula with the help of this technique. Here, if 2 pi is equal to L upon G is wrong, then in the third application, we can derive the time period of the simple pendulum by the dimensional analysis in the third application. But here, I think that you are thinking what is simple pendulum. In the case of simple pendulum, a heavy bar. For heaviness, we will select this bar, which is in the smaller side of the stainless steel, brass, heavy bar attached with the string or thread. But what is the condition? This bar must be heavy. This string is massless and torsion free. So this system is called the simple pendulum. In practical, we can't take a ideal simple pendulum because any thread, any string having no mass. It is not. It is not any condition. It is impossible. Having no mass, it is impossible. We can take the heavy bar by selecting materials, torsion free, each and every string having the torsion although very small. And if bar is attached with the thread, it is inextensible. There is no change in the length. It is also not 100%. If bar attached with the thread, certainly there will be the very small extension. So we can't arrange any ideal simple pendulum. So ideal simple pendulum is not possible. And with the help of this pendulum, we will measure the acceleration due to gravity in the 11th class experiment. Okay. The third application will be discussed in the next video. Thank you.